Horizontal range in projectile motion. Horizontal range means the distance covered along horizontal axis in complete projectile motion. That is to say, starting point and the returning point, the horizontal distance between them, it is represented by letter capital R. The initial velocity we considered was u, and its horizontal component would be u cos theta. When we consider the equation in horizontal direction has no acceleration. Horizontal velocity always remains constant. Then in horizontal direction we have only one formula, that is x equal to velocity into time. Velocity into time. Velocity will be considered the horizontal one, and that's u cos theta. From A to B, the total time taken is known as time of flight. Time of flight, and its value we know is 2u sine theta upon g. This is one formula for horizontal range. That formula is 2 by g. For range, you get the formula 2 by g into, you see, this is one velocity, this is other. Means 2 by g into both the velocities. What is the meaning of both the velocities? Horizontal and vertical, both. This is horizontal, this is vertical. Now suppose you use the symbol v1 and v2 for these velocities, then you can say horizontal range is this much, 2 by g into both the velocities. One very interesting and special case is considered here because you see 2 sine theta cos theta, this could be written as sine 2 theta, it becomes u squared sine 2 theta upon g. In order to find the maximum range, you are not going to change u and g. What is changeable here is only this theta. If you put theta 45, sine 2 theta would be 90, sine 90 is 1. In that case, this is the maximum value. Maximum range you are going to get is when theta has been chosen 45 degree. But don't be like robot here. This is applicable when you are having no upper boundary. For example, you are in a big hall that is having a smaller ceiling. And in that room, if you apply this condition, you are throwing something with 45 degree that will go and strike the floor, that roof. So this criteria is applicable only when you have no upper boundary, that is in the ground. For maximum range, you can choose this formula. Moreover, when you are throwing the ball from height, means you are playing with volleyball and you will throw this way. So you are not using the ground as a starting point. In that case, this angle needs to be little less than 45 degree. One more thing. Once you take the angle 30 degree, here you put 30 degree, you will find u square sine 60 upon g. Then you take angle 60 degree, here you will find sine 2 into 60, sine 120. You see, in both the cases, you are having these two values for range, and you know, sine 60 and sine 120, these will have same value, root 3 by 2. Better to say that both are the same. Let's conclude. If we are having the angle of projection as 30 degree or 60 degree, range will be same in either cases. And this is generalized by saying one angle is taken at theta and the other is taken at as 90 minus theta. If we consider two angles of projection as theta and 90 minus theta, horizontal range is going to be same in both the cases. Suppose in the two cases, ranges will be same, but time of flight will be different. Suppose in both the cases, time of flight are T1 and T2, then T1 and T2 product will be equal to 2R upon G. Now, this criteria or this condition that in order to get the same range, you have to choose the angle either 30 degree or 60 degree. See, angle 30 degree was chosen for firing of missile by one country to aim at some country of the enemy country, and that country is here. If 60 degree angle is chosen, this missile will reach the same place. Range is going to be same for 30 degree and for 60 degree. But the precaution has to be taken here. If the angle is taken 30, this building will be hit. If the angle is taken 60 degree, this building is not going to be hit, because in that case the trajectory will be little higher. So this very criteria is very particular and very relevant when war takes place between two neighboring countries. While firing the missile, this criteria is considered that angle should be chosen either 30 or 60. Well, now we'll see if some object is projected horizontally. For example, you are standing on the roof, and you throw some object this way, like this. In this case, the path will be parabola, no doubt. But if you have thrown from h will be equal to ut plus half gt square. We have chosen plus g because it will start going downward from the starting point itself. It becomes half gt square. And this range will be here equal to, if the initial velocity of projection was u, this will be equal to u into t. T you might take from here, it will be root 2 h upon g, u root 2 h upon g. This becomes the range here when the projection is horizontal. We always say that in projectile motion, the gravity is there and the path is parabola. But the fact is not that one. Actually, there is a little deviation because it's not complete motion, the gravity. If had it been constant value of g throughout, obviously the two angles will be same. It will be a symmetric curve. But since we know that g is variable with the variation in height, and not only that, there are other forces also like friction, viscous, dust particles. These will also hamper the motion of the projectile. When the velocity of projection is very high, like that of missile, this is no more a parabola. In that case, it becomes steeper. The descending part becomes steeper. And not only this, path changes, the range will also reduce a little this way. This angle has increased compared to this one. This angle will increase. Path is no more a parabola. This is known as ballistic curve. Instead of parabola, then we find ballistic curve, and based on these curves, we use the term ballistic missile for high range missile.